Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. CIDR, or CIDR, is a powerful and flexible way to define and represent IP address blocks. In this episode, we explore how prefix lengths are used to describe networks and subnets in both addressing and routing contexts. Unlike classful systems that rely on predefined classes, CIDR notation allows any subnet mask length to be applied. This approach has become the standard in nearly all modern network configurations and routing tables, due to its efficiency and clarity. The Network Plus certification includes CIDR notation as a key part of its subnetting, configuration, and address planning topics. Whether you're calculating host counts, summarizing networks, or identifying correct subnets, you'll encounter CIDR on the exam. The ability to interpret and apply this notation is critical when dealing with configuration files, routing diagrams, and addressing scenarios. Subnetting questions often require you to move fluidly between CIDR, binary, and decimal formats, making it essential to develop fluency in this representation. CIDR notation combines an IP address with a prefix length to indicate the size of a network block. It is written using a slash followed by a number that represents how many bits are used for the network portion. For example, 192.168.1.0/24 signifies that the first 24 bits of the address define the network, and the remaining bits define hosts. This compact format replaces the need for separate subnet mask notation and simplifies address planning and communication between devices and administrators. One of the major advantages of CIDR is that it removes the limitations imposed by classful addressing. Rather than being locked into class A, B, or C sizes, network designers can now create subnets of any size that fit the needs of the environment. This flexibility is crucial for supporting hierarchical addressing schemes, variable length subnet masking, and address summarization. Because it eliminates the need to conform to rigid class structures, CIDR enables more efficient and scalable network design. When reading a CIDR block, the prefix length tells you how many bits are reserved for the network portion of the address. The remaining bits are used for host addresses within that network. For example, a /26 prefix means that 26 bits are for the network, and the remaining 6 bits can vary for hosts. This relationship guides all subnetting calculations and determines the number of possible subnets and hosts. Understanding how to extract this information is a critical skill for passing the certification exam. Certain prefix lengths appear frequently in real-world networking and on the exam. A /24 prefix equivalent to 255.255.255.0 is common in standard local area networks. A /30 prefix offering only 2 usable host addresses is ideal for point-to-point links between routers. Larger blocks like /16 are often used in internal corporate networks that support thousands of devices. Recognizing the characteristics of these common prefixes helps you quickly assess scenarios and make accurate subnetting decisions. To calculate the number of usable host addresses in a CIDR block, subtract the prefix length from 32 to determine how many bits remain for the host portion. Then, raise 2 to the power of that number and subtract 2 to exclude the network and broadcast addresses. For example, a /27 prefix leaves 5 bits for hosts. 2 to the 5th power is 32, and subtracting 2 gives 30 usable hosts. This calculation is frequently used in subnetting problems on the exam and must be performed quickly and accurately. Every CIDR block includes a range of addresses defined by its network ID and broadcast address. The first address in the range is always the network identifier and cannot be assigned to a host. The last address is the broadcast address, used to send messages to all devices in that subnet. The valid host addresses fall between these two endpoints. When analyzing subnets, you must be able to identify all 3 values to ensure proper configuration and prevent communication issues. CIDR also supports block aggregation, where multiple smaller subnets are summarized into a single routing table entry. This process, also called route summarization, reduces the number of entries in routing tables, which improves performance and decreases memory usage on routers. For example, 4/26 networks may be summarized into 1/24 block if they are contiguous. Aggregation is especially important in large networks and service provider environments, where route table efficiency is a key concern. Modern routing protocols use CIDR notation to advertise networks with their associated prefix lengths. This allows routers to make precise decisions about the best path to a destination based on the most specific match. Classless routing protocols, such as OSPF, EIGRP, and RIP version 2, rely on this format to function correctly. Without CIDR, routing tables would be less efficient and less accurate, making classless addressing essential for scalable network operations. In subnetting exercises and binary math problems, the CIDR prefix length corresponds to the number of binary ones in the subnet mask. For example, a /28 prefix has 28 ones followed by 4 zeros in the mask. The number of remaining zeros tells you how many host bits are available. This binary pattern is important when converting between subnet masks, calculating address ranges, or determining how many subnets can be created. Mastery of this binary to decimal conversion is often tested in exam questions. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. CIDR notation is directly linked to traditional subnet masks, and converting between the two formats is a common exam task. For example, a /24 prefix corresponds to the subnet mask 255.255.255.265.0. A /26 becomes 255.255.192. These conversions help network administrators interpret and configure devices accurately, especially when working with older interfaces that require subnet masks in dotted decimal format. The ability to switch between prefix notation and subnet masks is essential for full comprehension of IP addressing. Access control lists often use CIDR notation to define which ranges of IP addresses are allowed or denied access to resources. This allows administrators to create concise rules that apply to multiple addresses using a single entry. Instead of listing every individual IP, a single CIDR block can represent an entire subnet. This approach reduces configuration errors and makes rule sets easier to manage. Understanding how to use CIDR in ACLs is useful for interpreting firewall and router configurations on the exam. CIDR is also critical in IP address planning. It allows network engineers to allocate address space based on actual site requirements rather than fixed class-based limits. For instance, a large headquarters may receive a /22 block, while a small remote office might only need a /29. This targeted allocation helps conserve valuable IPv4 space and makes it easier to scale the network as new offices or services are added. CIDR-based planning leads to more sustainable and adaptable networks. However, mistakes with CIDR blocks can lead to significant problems. One common error is assigning overlapping ranges, which can cause routing loops or address conflicts. Another is miscalculating host totals and assigning a block that's too small for the required devices. Misinterpreting the broadcast address may also lead to devices failing to communicate properly. These kinds of errors are often tested on the exam through troubleshooting scenarios or subnetting exercises, requiring careful attention to detail and accurate math. The use of CIDR is not limited to IP version 4. In IP version 6, prefix notation is used in exactly the same way, though the most common prefix lengths differ. A/64 is the standard subnet size in IPv6 networks, while /48 is typically used for larger allocations, such as those given to organizations. Unlike IPv4, IPv6 does not use broadcast addresses, so there is no need to subtract addresses when calculating usable hosts. Still, the prefix determines the network size and structure. Just like in IPv4, troubleshooting CIDR configurations involves checking that the prefix length matches the intended network size and that the address range aligns with the connected devices. It also includes verifying that routing tables contain accurate entries and that network address translation rules correspond to the defined blocks. Errors in prefix length can result in lost connectivity or misrouted traffic. On the exam, you may encounter questions that ask you to diagnose problems in a CIDR-based configuration. Many exam questions use diagrams to test your understanding of CIDR. These may show network maps with address ranges and ask you to identify which prefix matches a group of IPs. They may also require you to highlight the host range within a given block or determine whether two blocks overlap. Visualizing address groups and interpreting prefix lengths quickly is a skill that comes with practice. These types of questions are designed to assess your ability to apply CIDR knowledge in real-world-like scenarios. To become fluent in CIDR, consistent practice is essential. You should be able to convert between prefix notation and subnet masks quickly, calculate host ranges on the fly, and interpret diagrams with confidence. The more comfortable you become with these tasks, the easier it will be to handle subnetting problems under exam time constraints. Working through practice problems and real-world examples is the best way to gain this fluency. Mastery of CIDR is a cornerstone of IP networking knowledge. In summary, CIDR notation is a flexible and efficient method for defining IP address blocks. It eliminates the limitations of classful addressing and supports modern needs in subnetting and routing. The Network Plus exam frequently uses CIDR notation in questions that test your ability to read, calculate, and apply network ranges. Developing a strong understanding of CIDR helps you succeed not only on the exam, but also in designing scalable, efficient, and well-organized networks. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.